Okay, the difference about B related to A. Well, A was saying that the rope is getting pulled in at a constant rate, and then we were looking at how the speed of the boat was changing. But now it's saying the boat is getting pulled in at a constant rate, so we're seeing how the rate of the rope, the length of the rope is changing. So now we're looking for dH dt, given that the scenario is a little bit different this time. So we want dH dt. So again, we remember that we related the variables by saying x squared plus 144 equals h squared. So then 2x dx dt equals 2h dH dt. Remember, the derivative of that 144 is just 0, because the derivative of a constant is 0. Remember, this 12 is not changing at all, so its derivative is 0. It's just staying the same. There's no rate of change. Okay, so we want to find dH dt, so we have to use our given information. It says that h is 13, and we already figured this out in the last problem using Pythagorean theorem, that when h is 13, we found out that x was 5. So we know that x is 5. We have 2 times 5. And then what's dx dt? It gave it to us. It says 4 feet per second, so it's that negative 4 equals 2 times 13 times dH dt. Okay, we're going to be a little more careful about our simplification this time because we know the 2's are going to cancel when we divide. So we're going to get 2 times 5 times negative 4 divided by 2 times 13. That's our dH dt. Alright, so the 2's cancel. We end up with negative 20 over 13. Okay, negative 20 over 13 feet per second is how much the rate of change of the rope when there's 13 feet of rope out, given that the boat's moving at 4 feet per second towards the dock. To answer part B, we're going to do something similar to what we did in the last problem, where we just look at dH dt in terms of the variables. So dH dt, if we divide by 2x on both sides, it's just 2x over 2h times dH dt, dx dt, sorry. Okay. And we knew that dx dt was negative 4, so I'm actually just going to take that out and multiply by negative 4 instead. Okay. So then the 2's cancel, so we get that dH dt is equal to negative 4x over h. Okay, let's think about this again in terms of the picture. What's happening is the boat is getting really close to the dock, and 12 is staying the same. So if we have like a small, oh god, this is just a disaster to draw this this precise of a triangle. So there's 12, there's our boat length. Okay, just bear with me here. That's 12, that's x, right? Remember, h is becoming really close to 12 because this distance here is disappearing, so the rope length is just going to match the height of wherever the winch is on the dock. So h is going to 12. So as x gets really small, if we go over here, x is becoming really small, h is getting really close to 12, right? What's happening? We're dividing something really small by 12. 0 divided by anything is just 0. So dH dt is approaching a speed of 0. Speed of 0 as the boat gets closer to the dock. Okay, always go back to the picture. Just think about what's happening in the scenario, how the variables are changing, and how that's going to affect what we are looking for.